Hello, and welcome to OPA on AWS. My name is Zahi Ben Shabbat. I'm a prototype solution architect here at AWS. This is the fifth chapter, and today we'll talk about how to provision AWS resources and bind them to applications. Let's start looking at the common use case for provisioning resources. In the most basic example, we can think about an application that requires a database to read and write data from. In this case, the application will interact with the database, and the database only allowed to access by this application. We may have similar use case, but this time our application read and write files to a bucket. In the same way, we can have an application that push or pull messages from a queue. But a more realistic common scenario is having multiple applications reading and writing from a shared resource. For an example, we can have two applications reading and writing for the same database, or for the same queue. Before we demonstrate how this could work on AWS resource, we need to review the process of which resources are provisioned. When a developer selects a template of an app or resource, the platforms pull the predefined infrastructure as code, and that gets pushed into the repository of the app or the resource. Once the IAC code is pushed, it triggers a pipeline which deploys the infrastructure as code to the target provider. On a side note regarding resources, the IAC also contains permissions directory that will support policies JSON to allow access to that resource. We will discuss this in further details on resource binding section. We distinguish between application resource versus shared resource. While they are both AWS resources, the use case is different. In application resource, we describe the infrastructure as code to create the application. This includes things like container image repository, ECR, the task definition, secrets and SSM parameters, and possibly an S3 bucket to hold the state of the infrastructure if we decided to use Terraform. For shared resources, we create a resource with a predefined dynamic policy collector. This is done because we want to have a built-in capability to add policies that will grant access to that particular resource and capture those policies as part of the infrastructure as code. Let's take a close look how resource binding works. On the bottom, we can see the developer express an intent to bind an application to an RDS database resource. The binding process creates a new policy statement to grant access to App 1. Then the policy JSON is pushed into the permissions directory under the IAC of the application. That commit triggers a pipeline that applies the policy changes to the infrastructure, thus allowing the application to interact with this database. The developer can follow the same process to bind App 2 to the same database and have two applications bound to the same resource. In some cases, there may be a requirement to push policies both on the application and the resource. For those cases, the same approach can be used. Lastly, the single resource bind may actually include multiple statements. In this example, the application needs to access RDS database, but also the RDS secret for the connection string username and password. In practice, these are two separate policies that get pushed into the repo. Resource binding allows developers to create systems that are based on multiple applications and resources. Since it's all based on documented policy changes, we can also leverage the required approval on our pipelines to control changes to the IAC or the policies. We can also utilize backstage permissions model to control who can bind resources to application on the UI. First, let's look how do we provision a resource. So in our menu, we go to resource and we go to create an AWS component. We choose one of the resource templates that we have, in this case, an AWS RDS database. Then we have to fill in the name of the database and a description. Same as before, we choose owner of that database and the environment of which we want it to get deployed. We can choose from the several environments available. Then the more interesting part is that not only we can provision the database, we can augment the way the database is going to be created, given a particular database name or a schema name, but also choosing the type of engine of that database and also choosing the size. This could be useful for different environments based on the requirements of the business. Lastly, as before, we choose in a repo name and go and execute this. Will trigger the pipeline to create a database. To speed up the process, let's look at an existing database that we have, our commercial payment database US. We can see that the database is created in the same environment. We can also look at the CI/CD that execute the infrastructure as code to provision this database. But now let's see how do we actually use this database. You may notice that this database only have association to the environments, but it's not being used by any other app. So how do we make this work with an app? So now we switch gears into looking into the application, and let's say we want to look at the commercial banking US application. The commercial banking app currently is not associated with any resource, but let's see how we can do that. We will go to Management tab, and then we'll use the Bound Resource section on the bottom. When we click Add, it will show us the available resources for the associated environment, meaning you will only see resources available within the same environment. We can see that that commercial payment database is available, and we can go ahead and select it and click Select. What this does essentially create a change set that we're going to quickly take a look at. So if you look here, we have triggered a pipeline that basically build the changes to accommodate the permissions to this database. And you can see bind resources trigger. But before we even look at that, we'll let it run in the meantime. Let's look at what was the changes that were done. So in this case, we will want to go to the ISE directory and to the permissions directory and see that now we actually have generated two different statements. Why two? Because the RDS database needs to have a statement for the actual RDS, but also for the secret of that RDS. And they are separated by the particular environment and the particular type of statement this is. So if you look here, you can see we have full access for this specific database that we have asked for, and we have full access for the secret of that database that we asked for. Now, what actually happens once these policies are generated, all the pipeline has to do is simply look at those policies available and go and apply them. And we can see this happening right now. It's going to pick up those policies and apply them so the application can actually go and talk to that database. If the environment of which we run this pipeline will be a more sensitive environment, we can actually enable the require approval process. So somebody have to approve that change before the access is granted to this database. But once this is done, in a few more seconds, the connection to that database will be established, so our application can actually fetch information from that database, and we can read and write to it. Okay, now that the changes has been done, you can see that the resource of commercial payment database is now associated with this application. If we go to the management, we can actually see that the relationship is also established. But the more interesting part is that now, if we open our application, we can see that our application actually fetched data from the database. I hope you enjoyed this demo and thank you for watching.